All right, inverse functions. We got two parts to the definition I do want you to write down, and then we'll explain it in like kindergarten Mickey Mouse form here. Given a function f with a domain of D and a range R, its inverse function, and the way that we use that notation is, it looks like f to the -1, but that's just the notation for inverse function. Same with trig 1, sine to the -1 is actually inverse sine, okay, when we get to that. Given a function f with domain D and range R, its inverse function exists with domain R and range D such that the inverse of y equals x if f of x is y. What is this whole thing saying in layman's terms? It's pretty much saying that an inverse function is you just flip your x and y. That's really all it is, okay? If you remember that, you can put that. I need you to start looking at these definitions, though, and writing them down so you understand, if you do further on your calculus career, that many of the definitions look much more scarier than they really are, okay? So don't fear a definition. What is this right here saying? Again, all it's saying is here's your inverse, f of x equals y. If you flip it, you'll get f of inverse f of y equals x, okay? But here's one of the main important points for an inverse function. If you take the original function and like fog it, take put the f of x into it, you should get out x for all x in the domain. And we're going to do that momentarily. But I want you to know that's the main part of this. So, examples from homework tonight. You will have to find the inverse function. And I'm going to do 3 real quick. So let's do f of x equals x cubed plus 4. Let's do f of x equals x squared. And let's do f of x equals 3x over x minus 2. Okay, we're going to find the inverses. This will be easy breezy stuff. So here's all you have to do if you want to write down like a little note here. You switch the x and y and then solve for y. That's how anytime you have to find the inverse function, you switch your x and y and you solve for y. Now remember, this is your y right now. F of x is just a y. So we're now going to call this x, and wherever you see an x, you're going to call it y. And then you're going to solve this equation for y. So your algebraic skills should be on point right now. What would you do? Subtract 4 and then do what? Cube root. And then you can be fancy about it. You can write, oh, the inverse function is equal to the cube root of x minus 4. Like that. Okay, same thing here. You call this x, you call this y, and then you solve it for y. So to undo a squared, you take a square root. What should you remember when you take a square root or a fourth root? Plus or minus. So again, to write it fancy, plus or minus square root of x. Alrighty. And then this one, I do want you to know how to do this one. Let's call this x. And everywhere I see an x, put a y. How would you solve for y? times y over 2. Yeah, but I'm going to do it like this, but you are right. I would go like this. Like I always do this butterfly thing whenever I have an opportunity. So this is x times y minus 2x, I just distributed, equals 3y times 1, which is 3y. But now what do I do? Because everybody gets confused right here. If you did logs last year and understood it, this would be easy for you. Remember, you're solving for y. So what do I want to do? I don't want to divide. I got to get y by itself. Subtract what? Subtract 2x. Well, add 2x over here maybe, and then subtract. So kind of, remember, like flip-flop these two? So xy, yes, you could have. I know, subtract xy.
I meant plus 2. I don't know.
Yeah, it doesn't matter. It's fine. Either way, it'll still get you the right answer. I'm just going to subtract the 3y equals the add 2x over. Now, how do I get y by itself? Do you remember? Starts with an F, ends with actor. What are we going to factor out? Y. And you're left with x minus 3. And then what do you just do? Divide by x minus 3. So there is your inverse function. Okay? So just some easy things that you'll have to do for homework tonight. All right, now the last few things, here we go, is understanding this idea of what it means to be one-to-one, which I never taught one-to-one. And then Belky was all like, oh, I teach one-to-one to AFAM. What? But then I realized when I looked at how to figure out one-to-one, I was like, oh, I didn't know you could do that test on it, which I'm about to show you. Let me explain what one-to-one is. Again, it sends each input to a different output. It sends each x value to a different y. That would be considered one-to-one. And there's a test that you've known from last year, but we actually did it for something else. It's called the horizontal line test. Do you remember doing the horizontal line test? So last year, and I didn't know this, that's why when I read this book, I was like, what? It's new to me. The horizontal line test, I've always known that it actually tells you if its inverse is a function. It will tell you if an inverse is a function, but not only that, it'll actually tell you if it's one-to-one. A function f is one-to-one if and only if every horizontal line intersects the graph no more than once. A function f is one-to-one if and only if every horizontal line intersects the graph no more than once. So here's what they're going to do on homework tonight. They're going to give you pictures. Say, here's your f. Okay? And they're going to ask you, using the horizontal line test, is it one-to-one? Well, let's draw a horizontal line. Is it one-to-one? Why no? It intersected twice. Not one-to-one. Okay? Actually, I should say its inverse is not one-to-one. It's inverse. Okay. What about this one right here? Or the function is not one-to-one. Can I draw a horizontal line? Am I hitting it more than once? So this is one-to-one. And all that one-to-one means that if you put an x value in, you get a different y value out. Okay? All right, and then the last last two things, you'll have to graph a function, and I'm sure you all know how to do this. Graph a function's inverse. Let's graph the function and its inverse, actually, I should say. Okay, so if I graph this is the square root function. Where did I shift over? To the left 2, 1, 2, and it kind of shoots out like that, okay? When you go to find the inverse, you again switch your x and y. So this is x equals square root y plus 2. And I would have square both sides. Whoops. And I get y plus 2. So x squared minus 2 equals y. So there's my inverse function. So this is a parabola, but we're restricted on this domain. So we're only going to actually draw half the parabola just because of this domain is restricted. So what would this look like? This would be a parabola that's moved down 2, correct? So go down 2. And we go like this. Okay, now why am I making you draw that? Because I want you to see something that you remember from last year. There's this lovely magical line that goes right through. That looks terrible. That is a terrible diagonal right there. That line right there is the y equals x line. If you are an inverse, you should flip over your function, okay? These two should be able to flip over that y equals x line. So that's how I'll be able to tell on a quiz if you graphed it right. I just draw a y equals x line and I can tell that you graphed it correctly. Okay, it's really easy. You just switch your x's and y's and that one lands on top of that one. All right. Why is this also important? Because of our last thing. You can determine if two functions are inverses of each other. And this is our last thing. Determine if two functions are inverses. And they're going to give you an f of x. Make sure I have the right one down. 8x plus 3. And they'll give you another function, g of x. So they're not going to write it with the notation. And you have to determine if these two functions are inverses of each other. It's very easy. Very easy. If you can fog and goff, it's easy. To determine if they're inverses of each other, if they are inverses, the fog equals x, or the goff, actually. If you are inverses of each other, your fog will equal x. Then you have two functions that are inverses. So it doesn't matter whichever way you want to go. I'm going to fog because I just get used to that. So I'm going to say 8 times x minus 3 over 8, because that's what my x is now, and then add 3. And I'm going to make sure that I get out an x, not a negative x, not an x over 2, just x. So let's see, x's cancel. I'm left with x minus 3 plus 3. Hey, that cancels, and look what I'm left with. Okay, so these two are inverses of each other. I should have written g of x then as f inverse x. They are inverses of each other. And that's it. That's all this lesson was on. Okay, so you have that worksheet and booklet. And that's it. Hold on one second. Let me just stop this for my good buddy Jimmy.